Welcome, everyone. I'm excited to kick off today's presentation on a fascinating topic. We'll be exploring, understanding the fundamental differences between reactive content generation and proactive autonomous systems. Our focus will be on two major paradigms shaping the future of AI: generative AI versus agentic AI. In this session, we'll look at what sets these approaches apart and why they matter. So, let's dive in and discover how these technologies are transforming the landscape. So, while generative AI can produce impressive results across various types of content like text, images, code, and audio, it's important to remember that it still fundamentally depends on human direction for each interaction. Essentially, once the AI creates content, its role often ends unless a human provides another prompt to continue or refine the output. Think of it as a single transaction. It's waiting for your input, and then it generates an output based on that specific request. This is what we call a prompt-driven approach. The AI learns statistical relationships from massive datasets to predict what should come next, based on the patterns it has identified. Most importantly, this pattern recognition capability allows AI to excel at a core task, producing content in response to prompts. You see this in everyday tools like chatbots, image generators, and code assistants. These systems are reactive content creators. They respond to what we ask them, making them integral to our daily workflows. So, in essence, generative AI acts as a reactive content creator, powerful, responsive, but always guided by human input. All right, let's dive into how agentic systems operate through this continuous cycle. First, they perceive their environment. This is where they gather data and understand what's happening around them. Then, they decide on the best course of action based on that perception, using chain-of-thought reasoning to determine the most optimal move. Next comes execution, where the system takes action to move towards its goal. And finally, it learns from the outcomes of that action, which helps refine future decisions. This cycle, perceive, decide, execute, learn, is ongoing and self-sustaining, allowing agentic systems to adapt and improve over time with minimal human input. This is what makes them so powerful. They're not just reacting to prompts, they're interpreting them as goals and acting proactively. This shift from reactive to proactive intelligence marks a significant evolution. Instead of treating prompts as one-off requests, agentic AI understands them as objectives to achieve through autonomous, intelligent action. This is the core of the proactive problem-solving capability we're highlighting today. Let's take a closer look at some practical applications of these advanced AI capabilities. For example, agentic AI is perfect for ongoing management and multi-step processes. Think of personal shopping agents that can search various platforms, monitor prices, complete purchases, and even arrange delivery, all autonomously. It's like having a dedicated assistant working behind the scenes to handle complex, repetitive tasks efficiently. On the other hand, we have agentic AI mastery, which is ideal for content creation, brainstorming, and creative tasks. Here, humans remain in the loop to review and refine the AI-generated ideas, maintaining full control while leveraging the AI's creative potential. Despite their different focuses, both these approaches share a common foundation: large language models that power both chatbots and reasoning engines. The exciting part is that the future isn't about choosing one over the other. Instead, it's about developing hybrid systems that seamlessly combine these capabilities, creating more intelligent, adaptable, and collaborative tools. This convergence represents a future where AI acts as an intelligent collaborator, enhancing human efforts across a wide range of tasks. It's about blending automation with creativity to unlock new possibilities, making our systems more versatile and effective.